Hey guys, welcome back. This question was taken from a CJML individual contest back in 2015. No calculators are allowed. Let's get started. The question is, in the Cryptarithmic addition example, AA plus BB equals CBC. AA and BB are 2-digit base 10 numerals, and CBC is a 3-digit base 10 numeral, with A, B, and C the digits. If A is greater than B, which is greater than C, find the ordered triple A, B, C. Before I go into my solution, I'm going to give a hint. The hint is don't blindly guess and check, and start with trying to figure out the value of C, and based on that, calculate the value of A and B. To start off my solution, I want to find the upper limit of what CBC could possibly be. And I'm going to do that by replacing A with the max value it can potentially be, and same with B. So we know that A, B are digits, and since A is the largest digit, at most A can be 9. So that's its upper limit. And since B has to be at least 1 less than A, at most, B can then be 8. Now, using these upper bounds for A and B, we can find the upper bound for CBC by adding 99 plus 88. Now, when adding 99 plus 88, this goes back to elementary school maths. 9 plus 8 gives us 17. 1 plus 9 plus 8 then gives us 18. So, at most, the hundreds place in our answer can be 1. So, at most, C can be 1 since C is the hundreds place of our answer. Since C is a digit and it can at most be 1, it can either be 0 or 1. Looking at the equation over here, it doesn't make much sense for C to be 0 because if C was 0, then the hundreds place would have no significance. Also, if C was 0, then the equation would be AA plus BB equals B0, which once again doesn't make much sense because how can two positive integers AA and BB give a smaller positive integer B0? That's why C must be 1. So now that we solved for C, we can use this equation to solve for A and B. Now, before I move on to solving for A and B, another important thing to keep in mind is that when we solved for the upper limit for CBC over here, at most, 1 can be carried over from the ones place to the tens place. So we have two options, either 1 is carried over or 0 is carried over. Now that we know that C is equal to 1, we can form a few equations. Starting with the ones place, we get A plus B equals 1 plus whatever is carried over. We have two cases and we'll look into both cases. In the case that 1 is carried over, the equation looking at the ones place would be A plus B equals 1 plus 10, and if nothing is carried over, so in the second case, the equation would simply be A plus B equals 1. Now, C is 1, and we know that A and B must be greater than C, so they must be greater than 1. So it doesn't make much sense that two numbers greater than 1, when added, gives us a sum of 1. Therefore, case 2 is not right. That means 1 must be carried over. So this equation must be true that A plus B equals 1 plus 10. So 1 is carried over for sure. Now looking at the tens place, we get another equation, which is 1, which was carried over, plus A plus B equals 10 plus B. Since there's a B on both sides, they can be cancelled. And that leaves us with the equation 1 plus A equals 10, which simplifies down to A equals 9. Now that we have the value of A, we can plug 9 for A in the first equation here to solve for B. Doing so gives us 9 plus B equals 11, which implies that B must equal 2. So our answer is the ordered triple 9, 2, 1. But it always helps to check our work. So let's plug in 9, 2, 1 for A, B, C respectively and see if this equation is indeed true. Solving 99 plus 22, we get 1 carry over, 1 here, then 1 plus 9 plus 2 equals 121. And this seems correct because these three numbers are all the same, which is how it's supposed to be. They all represent B. These two numbers are the same, which is correct. And this number is the same as this number. And A is greater than B, which is greater than C. So indeed, the correct answer is the ordered pair 9, 2, 1.